Welcome back after the break, and let's continue looking at some settlement patterns. Now, I want to focus on the rural settlements. As you can see, rural settlements is unifunctional. It only concentrates on a primary activity, and as you can see in the surrounding of poles, you can see the farming taking place. Okay, now moving back to our urban settlements, it's multifunctional. As you can see, there's recreation areas, there's churches, there's schools, there's hospitals. So immediately we're not only focusing on primary activities, but secondary and tertiary activities as well. As you can see, there's silos over there, and there's a caravan park that serves as recreation. Okay, now another question that you might get is, where's the informal settlements? Now, for instance, informal settlements develop because of lack of services, because of rural-urban migration, and because of apartheid era. Black people were not allowed to move into the suburban areas or urban areas where the white people used to live. So you can immediately see where the informal settlements are. As you can see, it's on the outskirts of the urban areas. There's the urban areas. Mbekweni, there you can see, is an informal settlement on the outskirts. And as you can see, it's next to the sewage disposal works. It's probably where they lack basic needs and services. So that's all the information that you basically can draw from a topographical map regarding the settlement patterns. If you look at the orthophoto, very importantly, it covers this whole area over here. Now, in the case of the orthophoto, please pay special attention. So where this orthophoto has been taken is mainly over the urban settlements. And in your question paper, they might ask you to go and identify the numbers on the orthophoto, and you need to be able to determine which is which and how you're going to know what it is. You need to go and find the place on the topographical map that represents the number on the orthophoto. But let's continue with our notes. Now, our next section I want to discuss with you is GIS, Geographical Information System. Now, it consists of 15 marks in your final question paper. And like I explained to my learners is, if you know your definitions and your concepts, before I'm going to explain it, these concepts and definitions, I can guarantee you that you will get more than 10 out of 15 for this section. Now, GIS is relatively new to geography. It only started about 8-9 years ago. But this system has revolutionized the way we do things. So we basically integrated geography into technology. Now, the best possible way to explain GIS to you is, I'm going to give you a perfect example of McDonald's. Now, McDonald's is a global industry. It's a global company. It's $1 billion industry. It's usually successful, and we see it basically everywhere. But let's be honest with one another. It's $1 billion industry. It's usually successful because of hamburgers. But let's be honest. I prefer my Steers hamburger or my Rockamama's hamburger before I prefer my McDonald's hamburger. But now my question to you is, if there's so many hamburgers better than a McDonald's hamburger, why is those companies not as successful as McDonald's? And here's the key. Believe it or not, McDonald's used GIS, Geographical Information Systems, to allocate their McDonald's businesses. And I'm going to give you an example. Now, I want you to visualize this. If you think of a McDonald's, where do you find a McDonald's? At a busy intersection, close to a shopping center, and close to a school. So basically what McDonald's did, they found the right location to open their franchise. And in this case, you will always find a McDonald's close to an intersection, close to a school, and close to a shopping center. And with that, that's the reason they can sell more of their product, because they've got more consumers. And the reason why they're successful, they managed to find that property through the system of GIS. Now let's quickly have a look at GIS. It's an organized collection of computers, computer programs, geographic data, and people. So it consists of a bunch of components. People doing the work, data that's been collected with statistics, and computer programs, and it's all combined together. So if you look at this definition, that gives you all the components of GIS. Now what's the components? It's software, it's hardware, it's people, it's data, statistics being thrown in. Now in the case of McDonald's, they went and look, okay, where can we find a vacant property close to a school? Even better, where can we find a vacant property that's close to a shopping center and a school? Where can we find a vacant property that will be easy to construct, is not a steep slope, there's enough water, and we will have sufficient energy provision over there? So what do? We collect data from photos, from people doing analysis. We take a map with all the schools. Then we take another map with all the shopping centers. And then we take another map where all the busy intersections is. And that's how McDonald's plotted their franchises all around South Africa. And that's the reason why it's so successful. People who now know how to use computers as the hardware and programs as the software to provide the information, that's the geographic data, and able to solve a problem or answer to a specific question. Now, the following is very important for me. If you look at the concepts and definitions, now this is going to be asked in your final question paper with a multiple choice, or you need to match column A with column B. It's definitely going to be in there. So make 100% sure that you know these concepts and be able to define each and every single one of them. Now, if you look at the components of GIS, what makes GIS? I've just said it before in the previous slide. It's hardware, it's the computers being used. It's the software, it's the programs that we use. It's the data, the information. How do we get this information? Doing analysis, collecting information, ask questionnaires, people working with the hardware and software, procedures and the network. Okay, that's the components of GIS. Now, very importantly, we also look at spatial data. Spatial data refers to the exact position and object. Now, for instance, if you look at spatial data of your school, what is the exact location of your school? So we go to coordinates. The coordinates of the school is 23 degrees, 50 minutes, 55 seconds south, 21 degrees, 48 minutes, 30 seconds east. That's spatial data. That's the exact location about the school. Now, the next set of data that we use is attribute data. Now, that tells us something about your school. For instance, how many learners is in your school? How many teachers are teaching at your school? How many different races do we have in the school? How many black kids do we have? How many white kids do we have? How many rugby teams do we have? The attribute data is information that describes or gives the characteristics of the object. Now, what is the object? The object is the school that was found at that exact location. And the attribute data is information regarding the school. For instance, how many teachers are there, how many learners are there, what's the school fees. Another example, if we take an object, we take a tree, for example. The tree is found at that coordinates. What will be the attribute data be? It will tell us what type of tree it is, how old the tree is, and how many rainfall the tree might need. how much rainfall it might need, okay, and where it basically comes from. So that is information regarding it. Then we look at the vector data. It's spatial data stored in the form of coordinates shown as points, lines, or polygon features. Okay. Now, if I look at this type of features, an example on your topographical map is, for instance, a spotlight, a building, or a trick station. In this case over here, there's a post office. A trick beacon is over there, or a spotlight. Okay, it shows the data that's stored of the coordinates shows as a point. For instance, at that point, that spatial data is the trick beacon number 4 or the spotlight 1100. Now, vector data can also be line features. Now, if you think of line features, it can be perennial, non-perennial rivers, it can be a perennial river, or it can be farm borders, or it can be perennial rivers, or even transport lines. Polygon features is like cultivated land. If you look at it, build-up areas, there's cultivated land. That's another example of vector data. Or dams, that's blue in color. Okay, so that's the 3 features vector data can represent. Please remember, you need to be able to understand this concept and define it, and be able to identify this concept. Now, buffering is a term that we use to mark an area off. Now, if you quickly look at the definition, to mark off an area around an object. Now, we tend to use buffering, especially with rivers. All right, there's a river flowing, and then what we do is we buffer around the river, because most of our rivers are seasonal rainfall. And what happens during seasonal rainfall? What happens to the river's water level? It rises. So the floodplain will be flooded, the area surrounding the river. We're not supposed to build any infrastructure to go and live there, because we will experience flooding. So buffer zones are being created around an object to protect people from a dangerous situation. Because if you're going to build your house over there and the buffering zone wasn't there, what happens during seasonal rainfall? The water level increases and you're going to experience flooding. It might put your life into danger. So the buffer zone is there to protect us. So they put a buffer zone around the river. So you can only build your houses there, far away from the floodplain. Now there's the example. For example, along a river, people should live above the 50-year flood line as the height below which the river floods. Now we create a buffer zone for your home, so you won't be affected by the river floods. Now, as you can see, there's a buffering of a line string, a polygon, a point, and a multi-point, such as a nucleated area. Okay. And if we look at raster data is spatial data stored in the form of pixels. Now, you should know all what's pixels. If you look at today's day and age, you always want a phone with a higher resolution, more pixels. Now, you know exactly, you guys who like to take your selfies every single day, what does the pixels do? It clarifies the image. It makes the image more clear. Now that's raster data. Spatial data stored in the form of pixels. That is literally, where do we get that from? Think of orthophotos. Now where do we get orthophotos? Is vertical aerial photographs. And today's day and age, we use satellites to take images. That's remote sensing. I will get to that point now. So pixels are very similar to the blocks found on a topographic map. The size of the pixel block will determine how much detail an area will be shown. Smaller pixels show more detail. Larger pixels show less detail. Now, if you look at your camera, if you zoom in, you will start seeing the small little blocks. So that means the quality of the picture is not that great. How smaller the pixels, how more clearer is the image. Okay, so very importantly, the size of the pixel will show you how much detail it is. And obviously we want better pixel quality because it makes the image much clearer. Now you've seen it, if you zoom in, you can actually see the small little pixel blocks that's been represented over there. And if you look at remote sensing, it's taken a picture from far away. Now back in the days we used orthophotos, using vertical aerial photographs, a camera attached to an aeroplane. But these days we can take photos from far away. We don't even have to be in contact with it, for instance using satellites. And if you look at spatial resolution, that comes directly correlation with raster data, is how clear and easy the detail is to see. So we try to improve the spatial resolution to improve the pixel quality. Now, data layering is a tool that we use, like I've mentioned. That's what McDonald's used. They look at the data layering, and what they did over there, they took the reality of the map and they look at the streets and they decided, okay, listen, there's a busy intersection. That's already an advantage to go and build a McDonald's franchise. But then they need to go and have a look. Is there any buildings close by? Is there customers close by? Is there maybe a school? Oh yes, let's have a look over there. There's a school and there's a shopping center close by. So that's even better. We should buy ourselves land in this area over there. Then we go and have a look at the consumers. It's pointless to build. There's a busy intersection, but there's buildings, but the buildings are vacant. But is there people over there? So we go and have a look at the amount of people. We go and look at the population and say, right, we've got our customers, we've got the infrastructure, the buildings that we can maybe rent, and it's at a busy intersection. There you go. We're in for the money. We built our McDonald's right over there. Okay, so we use different sets of information in the data layering. Data sharing is the practice of making data used for each other, so we can share data. The police can share the crime statistics with McDonald's to maybe increase their security around them, or with the local community. Then data standardization is achieving agreement on common data definitions. So basically that everyone talks about the same principles and the same concepts. Data security is to protect the database from destructive forces. Now, how do we do that? You've got one on your iPhone. On your phone, you've got a password. If you've got a firewall to protect it, and that's the reasons why we install programs like Norton antiviruses, etc. And data querying is a process used to retrieve or getting data from the database. And the last one is statistical analysis. We collect information. Doesn't mean in any form how we can get it. We can do it through graphs, we can do it through questionnaires, and we can do it through computer programs. And what do is we combine them to report on an overall trend. For instance, let's use crime for example, especially the end of the year. It's known as silly season. People need money, so what's going to happen? If you look at the statistics, the crime will increase on the end of the year, and then we can do a report where does most of these crimes take place, and during what time of the day does it take place. Usually when the people leave for work between 10 o'clock and 4 o'clock in the afternoons. So that's what we do with the statistical analysis. We pull it together and we can write a report regarding the information that we've gathered. Now that's it for today. I hope you enjoyed the lesson and learned something today. See you next time around. Cheers.